Okay, so now we're going to be talking about circuit quantities. And some circuit quantities that we are interested in include the following. The first one, obviously, should be charge. Whenever we're talking about a circuit, we're talking about the flow of electrons. The unit for charge is in coulombs. Second, now, this is just because charge is more static. We want to deal with something that's more dynamic. So we also introduce current into the picture, and with the unit amps. The relation between these two follows a derivative integral relationship as given below. This is just to indicate an initial condition, whereas this is just integrating over the current. Similarly, with current also comes voltage. Now, voltage is expressed in terms of V, and the idea of voltage is a difference in potential between 2 points creates a voltage, or is the definition of a voltage. Now, formally, voltage we'll find out is a relative measure. So by probing across 2 points, we might have a different reading compared to another 2 points, but given the same reference. On another related note, we have work, because in order for circuits to kind of dissipate onto any element, capacitive, inductive, or resistive, it must do some work, and this is expressed in joules. With work also comes power. With power, we have watts. And these two are related to each other using the following equation. Power is equal to the derivative of work, whereas work is equal to the integral of power with respect to time, plus some initial condition if there's extra energy storage, like in the case of an energy like a capacitor or an inductor. Lastly, for the scope of this, we have frequency. In the unit 1/seconds, or because this is a tedious unit, we write it as hertz. Now, with all these 6 quantities, we're able to define most of circuit analysis, and actually most of circuits, using these 6 basic quantities. And the most famous quantities we always like to associate is the current voltage relationship. We also may want to talk about power or work in terms of power dissipation, or how much work needs to be done to do something. We also have frequency whenever we will cover AC analysis, and we want to show, or when we cover AC analysis, then we want to regard a certain parameter like a power factor or something. But these are 6 basic quantities that we are going to deal with. There are others that are definitely henries to denote inductance, farads to denote capacitance, and maybe Teslas if we wanted to talk about magnetic fields. However, these are what's known as derived units. And even then, current technically is a derived unit, where it would feel better that we cover these 6 basic quantities first, rather than covering these quantities down the line. Thank you. So that's just the point of this section. Okay, thank you.